Hey, this is Math 2, Unit 8, Worksheet number 1. Today we're going to be talking about properties of exponents together, and we're going to do some of the homework problems with you. So the first set here wants you to expand and evaluate. So what that means is we're going to take the 4 to the third power, and we're going to expand it by making that 4 times 4 times 4, because 4 to the third power means I have 3 4s in a row. And when I multiply 4 times 4, that gives me 16, and 16 times 4 is going to equal 64. So that's what it means when it says to expand it, and evaluate is meaning find what is it when you actually work it out there. We don't use the word solve because there's not an equal sign in this part. Okay, over here for number 3, let's look at number 3 real quick. 3 to the 4th power becomes 3 times 3 times 3 times 3. And so that becomes, well, 3 times 3 is 9, and 3 times 3 here is 9, and then 9 times 9 is going to be equal to 81. So sometimes it helps if you break it apart a little bit, so you can just kind of help it out. If I went 3 times 3 is 9, times 3 is 27, I may not know with some mental math 27 times 3. So that's why it might be helpful to do clusters of 9 and work that out there. Okay, now 4 through 6. It says rewrite expression using only one base. So we're going to combine things to have one base, and it says you do not need to work out the final answer. So when the bases are the same, what that means is that we keep our base, 3 in this case here, and when we're multiplying things of the same bases, we actually are going to add together the exponent values. So we have a 2 and a 5. So this becomes 3 to the 2 plus 5 power. Well, 2 plus 5 is going to be equal to 7, so our final answer will be 3 to the 7th power. On number 6, something similar here. Our bases are all 5, so that means our base will be 5. And now we take our exponents and we're going to add those together. So we have a 7, and then we're going to add a -4, and then we're going to add a 2. So 7 minus 4 is 3. 3 plus 2 is 5. So this becomes 5 to the 5th power. All right? Okay. For the next chunk, we're going to simplify these expressions. So now we have to start moving things around a little bit, okay? So first of all, for number 7, I notice that my whole numbers I can multiply as 7 times a 3, and 7 times 3 is going to be 21. Now for the a's, I have the base of an a and a base of a value there, so I have a squared times a to the 4th. That becomes again a squared, so I do the 2 up here and the 4 up there, because when I have the same base, I add the exponents, so 2 plus 4. So this becomes 21 times a to the 2 plus 4 power, or in other words, 21a to the 6th power. So I'm adding up those exponents, 2 and 4, to come up with a 6. All right, let's take a look at number 9. Same idea here. All right, we have a 4k on the outside, and we have 7j squared k to the 3rd. So in terms of the whole number here, right, we have 4 times 7, which is 28. Well, that's not a problem there. Now here I have a k, a j, and a k. So the j is going to still just stay j squared. No change there. It doesn't multiply anywhere else. It's just the j squared. But the k, this is actually k to the 1st power. All right, there's nothing there. It's k to the 1st. And so 1 plus 3 is equal to 4. So it becomes k to the 4th power there. Let's take a look at number 11. For number 11, 12, and there's no whole number there, so our integer number is going to be 12, no problem. Now for our bases, I have a base of an m and an m. Here I have a 5 and a -3. Well, 5 plus -3 is 5 minus 3, which is going to simply be 2. That becomes m squared, and the n is by itself, so that just stays n to the 5th with no change there. Number 13, now we move into ones where we are going to be having an exponent to an exponential power, a squared to the 4th power. When I have exponents to an exponential power, now I'm not going to add those, instead I'm going to multiply those. This becomes 2 times 4, okay? Because if you think about it, it's like this. This is a squared times a squared times a squared times a squared. Right? That is a squared to the 4th power, 4 times of doing that. If I was to do it this way, my base would be the same, a, and I would add these up. 2 plus 2 plus 2 plus 2. And when I add that up, I end up with 8. Well, is that the same as a to the 2 times 4 power? Yep, it sure is. That's still a to the 8th. So when you have an exponential value here, and it's exponent to another exponent, you're going to multiply that together. 2 times 4 is 8, so we have 8 there. All right. So for number, well, let's look at 14 real quick. All right, so 14 here, again, I would multiply this together. So -1 times a -3 equals a +3. So I'm going to have k to the 3rd power. All right, and that's how that works. For 15, we have 2x to the 4th power. So there's no exponent in here. I really just have 2x times, again, 2x times 2x times 2x. I'm just writing it out long ways so you can see what we're doing here. This is x to the 1st each time. So when I look at the 2 is 2 times 2 is 4, times 2 is 8, times 2 is 16. So I have 16 there. And the x becomes 1, 2, 3, 4, x to the 4th. Number 17, again, we have 5 squared, h to the 3rd, and all that is to the 2nd power. So first thing I want to do, I'm going to go ahead and do this bit on the inside real quick and turn that into 5 squared is 25 h to the 3rd, and now we're going to square that whole thing. Okay, so I can think about the square going with this guy and going with this guy here. So 25 squared, we'll write that like this, and then h to the h3rd squared becomes 3 times 2. Right, so I'm just doing each part there. 25 squared is 625, and the h part is 3 times 2, which is 6. So I end up with 625 h to the 6th power there. All right, let's look at number 19 together. Here I have 7 g to the 4th, h to the 0 to the 3rd power. First of all, let's look at this real quick. H to the 0 power is simply 1. That is just 1, that's all that it is. Anything to the 0 power, it has a value of 1, so we can pretty much just ignore the h. So now I have, if I break this apart here, I actually have 7 to the 3rd power, and then g to the 4 times 3 power. 7 to the 3rd is 7 times 7 is 49. 49 times 7 is 343. And g, 4 times 3 is 12. And the last one on this page here, before we flip it over, we have, first of all, I recognize that this part here is going to need to be squared before I can worry about that part there. So let's do the squaring here. So -6 squared is going to be -6 times -6 is 36. For the a, it's 2 times 2, which is 4. And for the b, it's 1 times 2, which is 2. So I have this part done, and we're going to multiply that by -3b. So now we do what we did before. 36 times a -3 is a -108. The a base has nothing to go with, so it just stays a to the 4th. And the b base is b and b. This is b squared and b1 to the 1st, so 2 plus 1, because we're just multiplying. We're not doing exponential stuff. So 2 plus 1 is 3, and that becomes our answer there. -108, a to the 4th, b to the 3rd. All right, let's turn it over on the back side. Look at a few more of these before we wrap up today's homework help. Okay, on the back side here, we start to see ones that have they're like a fraction, like a division sign type of thing. So if you think about it, this W8 and W3 can be written as W8 times W to the -3. Whenever I have that negative exponent, that would be rewritten, if I use positive exponents, by moving it to the denominator, or however that ends up being. You'll see later on, sometimes we put the negative down here, which means I got to put it up there. So when I rewrite it this way, as W to the -3rd power, when I rewrite this, now I'm back to having the same base and then adding 8 plus a -3, which is going to simply be 5. So if you think about this one here, I could do it long ways, or there's some shortcuts too, but let's look at this one the long way first of all. This is actually x to the 8th times, let's look at the x to the -2, because it's down below, we're going to put it up top real quick, times y to the 6 times, and here's y to the -4. So the bases of x I have 8 minus 2, which is 6. And then for the y's, I have 6 minus 4, which is 2. So that's my final answer for this one here. But what you notice is that you could simply just recognize, since they're already positive, that I could just do it without messing things up by rewriting. I could just do 8 minus 2 right there, which is going to be 6. And because it's 6, it stays up on top. And then 6 minus 4, which is 2, so it just stays up on top. The same idea. Let's try that method for number 24 real quick. Right? So here I have a 3 and a 9, right? So if I was to do 3 minus 9, I end up with a minus 6. So because that value is a negative 6, it would have to be down in the kind of the denominator basement. So if I think about this here, here's my answer here. I have a to the 6th power down here. For the b though, I have 7 minus 4, and 7 minus 4 equals 3, so that goes in the upstairs. So we have b to the 3rd power, like that. So that's what I end up with when I look at that one here. Let's take a look at number 25. This is m over n times m over n times m over n. That's what it means to go to the 3rd power. These are all to the 1st. Because we're multiplying, we simply add. So I end up with m to the 3rd power over n to the 3rd power there. Number 27, we're going to take this stuff in the parentheses and take it all to the 3rd power. Because the exponent, I got to multiply, right? So let's rewrite this here. X to the 1st, 1 times 3 is 3. Let's look at the y. 7 times 3 is 21. Draw our bar there. 3 times 5 for the x is 15. And then for the y, 3 times 3 is 9. Now I need to do some reducing to make this work out a little better. All right, I have 3 here, and then I have 15 there. So we know that the denominator is larger. So we could think of it this way. What is 15 minus 3? 15 minus 3 is 12. So 12 is going to be what's left there. If I rewrote this, this is the same as writing x, x, x on the top of the x's, and then 15 x's below. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that's kind of silly to write all that out, but I can reduce by canceling out. If I cancel these ones, 1, 2, 3, I cancel those ones, 1, 2, 3. So I'm left with nothing up here, but I'm still left with how many down there? 12. So that's where I get the x to the 12th value. Here I have 21 up top and 9 there, which tells me I'm going to have more y's up top when I'm all done canceling. And 21 minus 9 is equal to 12, so I have y to the 12th power. So my final answer is y to the 12th over x to the 12th. 29 is a great one because here we have this to the negative 1st power. And we've said when you have a negative value in an exponent, it means to move everything downstairs. Okay? So it's going to be rewritten as 1 over 2x. I'm taking 2x from the numerator and moving it downstairs to the denominator to make it to the 1st power. Okay, and I can rewrite it like this if it helps you see it better, but that's just something left as 2x. For 31, we'll do one of these, true or false. Is y to the m to the nth power the same as y to the n to the nth power? A true statement. Okay, is it true or false? I'm going to go ahead and say that it is true, and it says pick some values to show it. Well, here we go. Let's say that y had a value of 2, and that m had a value of 3. If I did 2 to the 3rd power and take that all to the 4th power, 3 times 4 is going to be 12, so it's really 2 to the 12th power. If I change, here I'm changing m and m, and here I'm changing back and forth. If I change that and say, well, what about this? 2 to the 4th power to the 3rd power, does that change anything? 4 times 3 is 12, so I still have 2 to the 12th power. So because those are equal, that's going to be a true statement. All right, that's it for today. We'll see you next time.